So here's an interesting problem that I got a question about. I'm told that these two figures are both regular polygons, and I'm asked to find the measure of this angle right here kind of formed between those two figures. So there's a couple different ways that you could go about finding this angle. Here's one. If you can see this one side that they have in common. If you kind of extend that out like that, then you can see this kind of breaks this angle here up into these two angles, this one right here and this one down here. And if I could find the measure of each one of those two angles, then I can just add them together and I would have the value of this whole angle x. Well, notice that each one of these angles is an external angle to one of these internal angles of each one of those polygons. Well, if I can figure out the value of this internal angle, then I just need to subtract that from 180 and I'll have that external angle. Well, I know how to do that because I know that if I construct this central angle here from the center of this pentagon, then I know that I can find the value of this central angle. That's just going to be 360 divided by 5, because I've got 5 of these same central angles. They're all congruent because it's a regular pentagon. So 360 divided by 5 is 72 degrees, which means this angle right here is 72 degrees. Well, this triangle formed right here I know is an isosceles triangle because both of these radii are congruent, because again it's a regular polygon, which means that these two angles here must be congruent. Well, so if I've got a triangle and I know this one angle is 72 degrees, that means those other two angles together must be, I'm trying to say 180 minus 72. 180 minus 72 is 108. That means these two angles must add up to 108 degrees, which means each one of them must be 54 degrees, because it's an isosceles triangle and those base angles are congruent. Well, notice I don't yet have this whole interior angle here, but I could do exactly the same thing that I just did for this triangle right here, and I'm going to get exactly the same thing because these two triangles are congruent, which means this angle here is 72 degrees, and these two angles here are both 54 degrees, which means that this interior angle here, let me try to redraw just kind of that one piece here. These two interior angles here, those two angles added up, that's 108 degrees, which means that this piece right here is going to be 180 minus 108, which is 72 degrees. So now I know that this angle right here is 72 degrees. Well, I'm going to do exactly the same thing with this bottom part, which is a hexagon. I'm going to draw this central angle right here, and I'm going to calculate the measure of that central angle. Well, that's going to be 360 divided by 6, because I have 6 of those interior angles in there. So that's going to be 60 degrees. And this one's actually a little bit easier because I know that that triangle is actually going to be an equilateral triangle. It's isosceles. That measure is 60, which means each one of these angles is also going to be 60, which means that this angle here is also going to be 60. So now those two angles together are 120, which means this angle over here is also going to be 60 degrees. And now I can see that the measure of that angle, that whole angle, is just going to be 72 plus 60, which is 132 degrees.